JavaScript Web Tokens, JWTs, or JWTs. Regardless of what you call them, you're likely using them every day when you engage with your favorite websites. They're the little bits of string that your web browser sends to the web server so the server knows who you are. Today we'll talk about what JavaScript Web Tokens are, how they work, and how you can implement them in your Python app. All right, before we actually look at what a JavaScript Web Token is, let's talk a little bit about what happens when you log into your online accounts. Typically what happens is you go to a website, you enter your username and password, that information gets sent over to the web server, and the web server checks the password. If everything looks good, it sends back a request to your web browser saying, all right, you can log in, and then you do what you want on that website. It's important to note that after that process happens, that authentication process happens, the connection between your browser and the web server is cut. Suppose later on you want to do something else on the website. Maybe you're on Amazon and you want to add an item to your shopping cart, or maybe you're on a social media platform and you want to like your favorite posts. Well, to do that, you would open a new connection to the server to let the server know what you want. But when you do that, you have to let the server know who you are. So the question arises, how does the server know that you're opening this new connection and requesting something? This is where JavaScript Web Tokens can come into play. Let's check out a diagram to see what I mean. All right, in this diagram, we have you on the left. This is us with our web browser. And then here on the right, we have a web server that hosts the website. And again, typically when you log into a website that has an online account, you first send your username and password to the server. The server then receives that password, checks it, and if everything looks good, one thing it could do is generate a JavaScript Web Token that represents information about who you are, and it will send that JWT back to your web browser. That little piece of code, that little token, is stored on your web browser for future use, and like we said, the connection is then broken. Later on, when you're adding something to your shopping cart, for example, your web browser sends that information back to the server, and along with it, it sends the JWT that it has stored. And then the server, once it receives the request, recognizes that there's a JWT included. It will then unpack the token, look at what information is inside, and use that to identify who sent the request. After that, the server does whatever it is that you asked and sends a response back. And then again, the connection is closed. And this happens over and over again as you're navigating on a website and trying to load new pages from that website. You're opening a new connection and telling the server who you are. One important part of this process is how the server verifies that the token it receives is legitimate, that it hasn't been tampered with or forged. And we'll talk more about how that process is handled by the web server later on in this video. But for right now, let's just jump into an example and look at a JavaScript Web Token. You might be wondering, what does the token even look like? All right, so I have a notebook here and I'll just put an example of what a JavaScript Web Token might look like. Let me copy one over. If you're wondering what a JavaScript Web Token looks like, it's just this, a long string of different characters. It looks messy, but life is messy and we have to deal with it. So let's do that together. This is an example of a JavaScript Web Token, and as we study it, I'm just going to store that in a Python variable called myJWT. If you look closely at this string, you'll notice that it's a series of characters and numbers, maybe a few symbols, and if you look very closely, you might notice that there are 3 sections here separated by periods. And we can verify that. If we look at our string and split on that period, we'll find that we do in fact have 3 different parts, 1, 2, and 3. This is the first thing we'll note about JWTs. They have a structure of 3 parts separated by 2 periods. The first part is called the header, the second part is called the payload, and the third part is called the signature. And each of these parts are very important. We'll talk about what they do in the whole authorization process. To begin with though, let's just check out the payload, which is kind of like the core or the meat of what the token is. Both the header and the payload are typically base64 encoded, and that's just a way of saying that you have a string that's been converted into another format. Because it's base64 encoded, we could decode it to see what this information is. So let's do that. Let's import our Python module base64, and then we'll see if we can take our payload, our encoded payload, and decipher what information lies inside. Let's do payload encoded is what we just copied. And what we could try to do is use our base64 package to decode our string. Now, when we do that, expect to receive an error because of padding issues. And here it helps to know a little bit about what base64 is. There's different variants or different formats of base64. The standard variant says that you have to have a number of characters that's a multiple of 4. Think 4, 8, 12, or something else. The JWT standard, though, kind of skips over that rule and just has as many characters as are necessary to encode our data. So to use this function to decode it, we need to make sure that we have a multiple of 4 by including a padding parameter or a padding character. So let's do that. Let's create a function that does a little bit of modification to our payload before we try to decode it. We'll make a function, let's say base64 URL decode, and we'll take an input of a string, and we'll do a few things. First, we'll take the input and convert that into a bytes object by encoding it, recognizing that it started out as UTF-8. Oh, I have a typo here. And then after we have our input as bytes, we'll do a few things. We'll first see if we need to apply any padding for proper base64 encoding, and then we'll try to decode the input itself, or we'll try to base64 decode the input. Okay, so let's see how we can do that. If we want to determine the need for padding, we first need to figure out how many characters are in this input. So we can do that by taking the length of our input and performing a modulo operator. We can then divide by 4 and figure out what the remainder is. Ideally, we have a input that has a perfect multiple of 4, but if not, we'll need to add a padding character to get to a multiple of 4. I'll store this as a variable remainder, and so this will just tell us how many characters are left over after we try to divide the number of characters by 4. And if we find out that we have some kind of remainder that's not 0, think of it as 1, 2, or 3, then we'll need to take our input and append some characters to it so that we get to a multiple of 4 characters. So we'll take our padding character, which is the equal sign in the base64 standard, and we'll add as many as we need to get to a multiple of 4. All right, so let's look at what this is. This is basically saying, hey, what's the remainder after a divide by 4? If I have a remainder that's bigger than 0, let's figure out how many more characters we need to get to a multiple of 4, excuse me, typo there, and then add that many equal signs to the end of our input bytes. Once we have that, we should have an object that has a multiple of 4 characters, and we can use our standard decode function from the base64 module. Let me do that. Let me bring that into our function, and instead of decoding this, we'll decode our modified input, and we'll return it and see if this works. Let's try decoding our payload by using our new function and passing in our encoded payload. Oh wow, look at that. We had a string that looks like a bunch of gibberish, and once we run it through our base64 decoder, we start to see something that looks a little bit more understandable. We see a sub, our famous Harry Potter, and a few numbers and other characters. If you look closely, you might notice that we have some curly braces, and you can probably recognize that this is some kind of JSON object. And you're right, this is a JSON object. So let's do a little bit more to our decode function to make this more readable. I'm going to import our JSON module, and one thing we can do before we return our decoded value is just turn it into a Python object just to make it a bit more readable. Let's do that. So here we have a string that is returned, or sorry, a bytes object that is returned. We can then decode that into UTF-8 so we get a string object. And once we have that, let's put that in a variable called output string. And just to make sure that works, let's check that. Okay, now we get a string object instead of a bytes object. And what we could do is convert that into a proper dictionary by using the JSON module's load string function. And we'll return that dictionary instead. Oh, I have messed up. Let's see. Name J. Oh, you know what? I don't think I ran this. There we go. All right, I forgot to load or actually run the cell. Now that we've done this conversion at the end, we can see that we have a dictionary or a JSON object representing a little bit of information about our user. This is the payload portion of the token. The payload is typically what identifies the user or some entity, so the web server knows who it is that sent the request. If you look here, you'll notice that there are in this token 5 key value pairs, and some of these are pretty common among the JWT standard. None of these are required, but they are recommended. Often you'll find a token that has a sub value that stands for subject or user. In this case, our subject is Harry Potter, or the user is Harry Potter. After that, you have a couple of keys called IAT, EXP, and NBF. These are all times that essentially tell you when the token was issued or when the token is valid. And the last key that we have in this token is AUD for audience. That tells the web server who the intended audience of the token is, or what audience should receive the token for usage. Let's look at some of these times. IAT stands for issued at. That essentially tells you when the token was created. EXP tells you when the token was expired. And NBF tells you the time before which the token is not valid. These are timestamps in Unix time, and if you're not familiar with it, it's just a way of storing time in databases or different data systems. To turn this into something that's more human readable, we can use Python's datetime module. Let me import from datetime the datetime object, and I'll go ahead and import time zone and time delta in case we need them later. Okay, let's see what these times look like. We could take our datetime and use the method from timestamp and pass in these integers to see what time this token was issued. Running that, we get a date time of today, December 31st, 2024 at 9:21, which is local time, central time for me. If we look at all of these together, we can quickly just see all of the time information in the token at one glance. So let me do that. I'll just make 3 print statements. Got NBF. And let's see what we have. All right. It looks like this token was issued today at 9:21. It should not be valid before that same time, today at 9:21. And it looks like this token expires about 2 hours later at 11:21. Altogether then, what this token is saying, or what this payload is saying, is that our subject or user, Harry Potter, has access to the ASCII Cookies website between these times, basically between 9:21 and 11:21 today. After which, or before which, the token should not be valid and he should not be given access to the website. Pretty cool. At this point, you're probably wondering, hey, how does this stop any shady business? What's stopping me from creating a token with Harry Potter's name and then logging into his account and using it for my own needs? This is where the other parts of the JWT come into play, the header and the signature. Let's decode the header so we can see what it is. We have our full token right here in our example. The header is the first part. I will come and bring that down here, store it in a variable called encoded header. And let's use our same function that we created to decode this header to figure out what these characters represent. So this is our header. The type of JWT tells us that this token is a JWT. ALG stands for algorithm, or the hashing algorithm that's used later to create a signature. So let's talk about hashing. Let's talk about the signature part of a JWT. When the server decides to create a JWT containing information about the user, it'll do the following steps. It'll first take a header or create a header with the type and the hashing algorithm. It will generate a payload. It will base64 encode both of those and combine them with a period. And then it will hash that combination using the algorithm that's defined in the header. And that effectively creates the signature. One important piece in that hashing algorithm, or requirement in that hashing algorithm, is a secret key or a secret string that is only stored on that server. No one else ideally has access to that secret key. With those pieces of information, it creates a signature that is then added to the JWT as that third part before being sent back to the browser. So let's actually jot that down because it's a little complicated, but it makes more sense when you see it all spelled out. When we are creating a signature, we are effectively taking three pieces of information. We're taking our encoded header that has already been base64 encoded. We're combining it with a period and adding to that our encoded payload that looks like this. We're also then determining what hashing algorithm we want to use. In this case, we see that the algorithm is HS256. And we're also passing in a secret key that is only on the server. These three things are then needed to create the signature. And then in the future, when the server receives the token again, it will look at the payload, it will look at the header, and it will hash the combination of the two again using the hashing algorithm in the header and the secret key that's on the server. And it will compare the hashed value that it created on the fly with the signature that's stored on the JWT. Those two values should match, and if it does, that means the server can trust the JWT that it hasn't been tampered with or forged. But if they don't match, then the authorization process should fail because something's wrong with the token. And that's why I can't just create my own token and send it to the website using someone else's credentials. In order to create a JWT, I would need to have a signature that passes that validation process. And to create a valid signature, I would need to have the secret key that is only stored on the web server. And that's the beauty of JWT. You can store information about the user on that user's web browser while still having a little bit of security to make sure that when that JWT is returned to the server, it hasn't been tampered with. All right, so let's suppose that you want to implement JWT as part of your authorization process for your Python web app. If you do that, there's two things that you need to take care of. Your app needs to be able to create a JWT and then also validate any JWTs it receives in HTTP requests. Luckily, you don't have to reinvent the wheel. There is a very handy Python package called PyJWT that does that for you. Let's check out how you might use PyJWT to integrate authorization into your app. Let me create a new section. We're going to look at PyJWT, and in particular, we'll look at how you can create a token and validate it. All right, I'm actually going to cheat a little bit and go to the docs for PyJWT. When you go to the docs, you'll see that you can install PyJWT using pip or your favorite package management system. If you want to create a token, you simply import JWT and use this function to create a token. I'm going to copy that and paste that in my notebook. Okay, and you can read the docs to see how to use it, but we can figure it out just by looking at this example. Here we have in the JWT module a encode function, and it's going to take some payload, some secret, and some algorithm to create our token, much like the three pieces that we looked at up here. So let's create a payload first. It's basically just a Python dictionary with some claims about who the user is. We can include our common claims of the subject. For this example, let's say that we have our subject being Albus Dumbledore. And then we can include some information about time, like when the token was created or when it should be valid. We could create a IAT claim, a not before claim, and then a expired claim. And just for kicks, we could also say that this token is expected to be used by our super magical website and no other website. Let's use our datetime module to create some of these pieces of information related to time. From our datetime module, we could use the now function to create a datetime object that represents now, and that would be a good thing to use for our issued at timestamp. It's not good to just leave it in this format. This is a naive datetime object, and Python wouldn't know which time zone we're looking at. And so where possible, it's always good, if you can, to include the time zone. I'm going to use time zone UTC. And this will give us the same timestamp or close to the same timestamp, but now in the UTC time zone. Let's store this as a variable called now. And I'll put that in here, and we can say that the token was issued at now. Makes sense that the token should not be valid before that same timestamp. If we wanted to create an expiration date, we could just say now plus sometime in the future. I'm going to use time delta, and let's just say 2 days from now, I want this token to expire and no longer be used. Let's check this out to make sure it's looking as we expect. All right, so far it looks pretty good. We can then take that payload and pass it to our PyJWT encode function. And we're done with the first part. Okay, next we have a secret. This is the secret key that is only stored on the server and known to the app, and then the algorithm itself. Let's look at the secret. Spoiler alert, the secret key of secret is a terrible, predictable secret key. So let's create something that's a bit less predictable. Here in my terminal, I'm going to use the OpenSSL command to generate some random characters that can be used as part of my secret key. I'm going to use the OpenSSL ran command with hex 32 to generate some random hex characters, 32 random hex characters. And if I run this over and over again, you can see how each time the output is different. And I'll take this one and make that my secret key to be used as part of my token creation. I might need to use that later to validate any future tokens. So I'm going to store that in, oh, I did not copy that. I'm going to store that in a variable called secret key, and then use that as an input for my encode function. Last, we can use different hashing algorithms. HS256 is a good one. It's very commonly used. I will use that, and rather than hard coding it in the function, I'll create a new variable, let's say maybe signing algorithm, that defines that value. All right, so I think we have everything we need to create a token. The JWT module will encode our 3 pieces of information and output a token. Let's see what that token looks like. There we go. We've just created a JWT. We can see the 3 components here. Again, they're separated by period. There's that first one, and here's that second one. with the signature at the very end. Excellent. All right, so this is the token that would be sent off or sent back to the browser after the authentication process is complete. Now, when it comes to authorization, later when we receive the token, we'll want to make sure that the token is legitimate, that it's valid for certain timestamps. The PyJWT module makes it really easy to do that, and we're going to cheat again. We'll go back to our documentation and copy paste a similar function called decode, which will effectively do two things. It will decode our token and validate that it is legitimate. So let's do that. Let's decode our encoded JWT. Again, you can look at the docs. We'll just figure it out. Here we need our secret key so that we're creating the right hash of the payload and the header. And then for the algorithms, we just need to tell this function what algorithm we used. When we first run this, we should run into an error. And the error says you have an invalid audience. That's another way of saying, hey, this token is declared to be used by a certain audience, and that's not us. And that's because we haven't told the decode function what audience to expect in the token. Let's go to our documentation and let's see, we can look at usage examples and just search for tokens that have that audience claim. And you'll notice here that in this decode function, you can pass in the expected audience as the argument audience. We'll take that and pass that in here. And in our case, the audience is expected to be Supermagical website. You know what? I should actually store that in a variable as well so that I can reuse it both when creating the token and when later validating it. Okay, so let me quickly just regenerate a new token and pass that AUD into the audience argument. Let me clean this up a little bit so it's easier to see. Okay, let's see if this works. There you go. So we see that our token has been validated, and we can see that the middle part, the payload, has been extracted and returned. We could then return this or store this in our app as a variable and use that information about the user to perform whatever logic our app needs to perform. Now, it may just look like this decode function from the JWT module is extracting the payload and decoding it for us, and it is doing that, but it's doing a lot more behind the scenes. It's performing a lot of validations to ensure that the token that it receives is valid. We already saw how it had an error message for when we did not tell the function what audience to expect. Let's just simulate what would happen if we received a token that was expired, for example. Let's create a new token with a new expiration date. We'll say some other time for when the token was created, and let's just make it 2024 January 1, and I think we can pass in the time zone like this. Let's check that really quick. Oh, nope. There we go. I knew we'd get there eventually. So this could be our other time that our token is created. And rather than having our token issued now and expire now plus 2 days, we'll just say that the token was issued at some other time in the past and that it expired 2 days after that some other time, which is still past. We'll create this new token, and when we try to validate it, we'll get a helpful error message that says expired signature error, which is another way of saying that, hey, the token's expired. And these are some of the things, some of the validation steps that JWT handles out of the box. If you look in the API reference and look at the exceptions, you can read through the various types of checks that it takes during the validation process. We've already seen the invalid audience error and the expired signature error, but there's all kinds of errors that it checks for, like invalid issuers, issued at, so on and so forth. And that's how you can use JWT in your Python application. There's a handy package, PyJWT, that handles a lot of the foundational elements right out of the box. If you want to learn more about JWTs, there's a really handy website called JWT.io. What I like about this website is right on the front page, if you scroll down a bit, there's an interactive tool for you to look at your encoded token and see how the decoded components look. It's very nice, color-coded. You can see the header, the payload, and the signature here. And we can test out our token here by just copying it and pasting it directly into the website. Let me clean this up and take off the quotes. And we can see that after I pasted the token in, it decoded to find the header and the payload. And it also does a little bit of verification. In this case, it's saying, hey, the signature here is invalid. And that's because we haven't told this website what our secret key is. Remember that when the signature is validated, what our server is doing is taking our header, combining it with our payload, and then hashing that combination with some kind of secret key. And if that hashed value matches the signature and the token, then it's good. Let's quickly tell this website what our secret key is. And once we do, we can see that the signature is in fact verified. Pretty cool. All right, so that's a little bit about JavaScript Web Tokens. They're a way to store information about the user on the user's web browser, and built into the design is a way to ensure that the token generated by the server hasn't been later on tampered with or forged when it receives future HTTP requests. Hope you enjoyed, hope you learned something. If you like what you see, please like and subscribe below. And if you have any questions or suggestions, please leave a comment below. Until next time, happy coding.